For centuries, indigenous farmers and homesteaders knew which plants kept their gardens healthy without synthetic sprays. Among these, one plant stands out, quietly working beneath the radar of modern horticulture. While it is native to countless regions, it is often dismissed as a weed or ornamental. Yet historical accounts from early North American, European and Asian gardens reveal that this plant repelled insects, reduced fungal outbreaks, and even supported beneficial predators that controlled pests naturally. When I integrated it into my own beds, the results were immediate. Aphids, caterpillars and root maggots all diminished, and the garden thrived through every season. The plant works because it produces natural compounds that disrupt pest behavior. You know, scientific studies confirm what ancient gardeners observed centuries ago. Essential oils, resins, and these fascinating secondary metabolites emitted by the plant actually repel herbivorous insects, while interestingly leaving pollinators completely unaffected. Unlike chemical pesticides, these natural compounds are, well, subtle, yet remarkably persistent. The plant doesn't just, mask crops. It actively conditions the microenvironment around them. When you plant it in borders or intersperse it among your vegetables, it forms a living barrier that, quite simply, reduces infestations and supports overall plant vigor. It also supports beneficial insects and predators that really help enforce natural pest control. Historically, this plant was often placed alongside fruit trees, vegetable plots and herb beds to attract ladybugs, lacewings, parasitic wasps and ground beetles. These predators thrive on the nectar pollen or shelter the plant provides. In practice, adding it to a garden increases the population of natural enemies to pest species, creating a self-regulating ecosystem. In my own trials, I noticed a dramatic uptick in ladybug activity within 2 weeks of planting, which correlated with a sharp decline in aphid populations. The plant improves soil health while simultaneously defending crops. Its root system penetrates compacted soil, aerating it and promoting water infiltration. Decomposing leaves release nutrients slowly, enhancing fertility without disrupting soil microbes. This dual function, soil improvement and pest deterrence, is one reason ancient gardeners favoured it. Unlike chemical interventions that can harm soil life, the native plant harmonizes with the existing ecosystem, strengthening both plants and microbes over time. Integration is simple but requires strategic placement. Ancient practice shows that planting in rows, clusters or as a continuous border really maximizes its protective effect. In my own vegetable beds, I planted small patches every 2 to 3 meters, ensuring coverage without crowding crops. Around fruit trees, a wider perimeter allowed roots to mingle with tree roots, which honestly enhances soil benefits. For perennial beds, clusters near the base of susceptible plants created microclimates that discourage pests and, moderated temperature extremes. It works year-round, even in harsh climates, which is rather impressive, I must say. Unlike annual companion plants that die back and leave gaps, this native species survives frost and drought, providing continuous protection. Historical herbals document its use in northern climates where winter pest management was critical. In my garden, it retained foliage late into fall and emerged early in spring, creating a living scaffold of defense for crops from the first shoots to the last harvest. Maintenance is minimal, but, timing really does enhance results. Pruning is recommended to prevent overcrowding and to stimulate new growth, which produces the highest concentration of pest-repelling compounds. Leaf litter can be left under the plant to return nutrients to the soil. Historical gardeners noted that slight disturbance, cutting or harvesting leaves, did not diminish pest protection. It often enhanced it by encouraging fresh, potent growth. The plant can actually be combined with other native species for, integrated defense. Ancient polyculture systems frequently paired it with nitrogen-fixing legumes, aromatic herbs, or flowering perennials. The combination created layers of defense. Companion species improved nutrient balance, attracted pollinators, and provided additional shelter for predators. In my experiments, a mixed patch of the native plant with clover and dill reduced pest pressure on adjacent vegetable rows more effectively than single-species plantings. Modern gardeners ignore it at their own risk. Synthetic pesticides offer convenience but harm beneficial organisms and disrupt soil structure. By contrast, this native plant is low cost, low maintenance, and highly effective. Its long-term impact exceeds that of short-term chemical solutions because it improves soil, encourages biodiversity, and maintains pest suppression continuously. It demonstrates that ecological wisdom from historical gardens remains relevant today. Success lies in respecting ecological principles rather than forcing shortcuts. Historical use shows that consistent placement, minimal disturbance and strategic timing amplify results. It is not a quick fix, but a living system that responds to care and observation. By observing its growth cycles, monitoring pest populations, and adjusting plant distribution, gardeners can achieve what historical farmers achieved for centuries: a productive, resilient, and largely pest-free garden. If you want to harness historically proven pest management, improve soil health naturally, and cultivate a self-regulating garden ecosystem, subscribe to Botanical Bliss, share this guide with fellow gardeners, and reintroduce the native plants our ancestors used to keep their gardens thriving year after year.